So guys, welcome to today's session on structure of amino acids, and just let me know if I am live. So this session is around structure of amino acids, and we will have a theory, look at the theory portion of the this topic, along with understanding on how the questions are going to be asked on this particular topic. This is one of the most basic topic for amino acid, and what happens is this is also one of the topics which will which will have a lot of questions also on very directly or indirectly. Now one important thing which I want to tell you is what happens is if you see, there is this phase in which there is a transition from current NEET PG to next pattern examination. And a major difference, if you see in the questions which have been asked in this year NEET PG for any subject, even the preclinical subject or paraclinical subject, is the focus is now more towards clinical questions. So the same point, even preclinical question point, is now being asked in a more clinical way. Okay, so basically that is why a deeper understanding of these topics are from a clinical point of view. So the topics have not changed. First of all, let me tell you that you need not worry. The topics for the high topics are still the same. The kind of questions are changing. The topics on which the question were earlier asked, now they will be asked from a different angle. So this kind of session, so in next throughout the year I'll be taking these kind of sessions, 30 minutes, 30 questions on some high topic in biochemistry. So the idea will be to review that particular topic and to give you a complete background on what kind of questions can be asked on that particular topic. So just give me a heads up, guys, if you can hear me properly, if the audio of this particular session is okay, just give me a heads up. I'm just also seeing whatever you can. Hi Anpurna Reddy. Hi Jatin. Okay. So now I'll begin the session. The session has been sponsored by Unacademy. Now Unacademy foundation batches are going to start from 15th of January. So we'll talk about it in a while, after the session in a while. So if you don't know, I'll talk about it, but let's quickly get into the session. So we'll first start by understanding the general structure of amino acid. Now, general structure, it's very simple. If you see, there is a carbon, right? And there are two functional groups, amino group and COOH group, that is acid group. So it has both acid group and a base group, right? And that is why the name amino acid is there, okay? Because it has an acid group and it has an amino group. Is it clear? Now, it has an hydrogen, and fourth attachment to the carbon is what is variable and is what will be different in various amino acid. Okay, so these are the four. So if you know, carbon can attach to 4 different atoms at the same time. Now in an amino acid, these 3, the first 2 functional group, the third hydrogen, is same for all amino acid. It is this 4th functional group, right? The 4th attachment which is different for every amino acid. Okay, is it clear? So for amino acid, and very important to understand is these two, this is a base and this is an acid. So amino acid is an amphiteric molecule in which acid and base both are present at the same time. Okay, so this concept everyone is clear now. So first I told you that amino acid has both acidic group, okay, and both base group. Okay, and second concept I have told you is that only the side chain, the R, is different for various amino acids. Right. The second thing is what we will talk about is the concept of alpha carbon. If you see this carbon is what is having both the functional unit attached. Okay. This first carbon is having both the functional unit. What are the functional unit? The amino group and the acid group. So this is called as alpha carbon. Okay, so is these concepts clear to you? General structure of amino acid. So general structure of amino acid, it has 3 groups which are same for all amino acid, and the last group, this R, is what is variable, is what make one amino acid different from other, right? and the first carbon is called as alpha carbon. So this is the basic structure of amino acid. If you see, I have made it COO negative. Okay, so what happens that COH, okay, this hydrogen can be easily lost whenever there is a base medium. I'll talk about it in a while. And here the NH3 can easily accept an hydrogen. Okay, so another representation of this amino acid can be like this. So don't get confused in the examination if they show you this structure and ask what it is. Okay, and this is the variable side chain which I was talking about. Now some theory points will be, most amino acids are alpha amino acids. So it can be given as which of the following is true regarding amino acid, and most amino acids are alpha amino acids can be one of the topics. Okay, so this is here. The very important MCQ point will be non-alpha amino acids. So we know that most amino acids are alpha amino acids. Alpha amino acids means this is the alpha carbon. Why it is alpha carbon? Because it is here both the functional groups are attached. Okay, now the MCQ question which will come is, what are the non-alpha amino acids? Okay, and we already know these are very, very important amino acids: beta alanine, beta amino isobutyrate, and gamma amino butyrate. So these are certain very important non-alpha amino acids. Okay, so this is Jatin, I'll definitely discuss that question. Okay, so this is the general structure of amino acid, and these are the two questions. Now there is a third thing which you need to know, that is amino acid. Okay, so concept of amino acid. If we see proline, so proline has this structure where this is C, this is COOH, this is hydrogen here. Okay, and here we have got NH2, and we have a 3 carbon side chain. Now what happens, this 3 carbon side chain, this carbon forms a cyclical structure with this nitrogen, as you are seeing in this diagram. Okay, this is the first, second, third side chain carbon. But what happens, the third side chain carbon forms a structure, a bonding with the amino group. So this is called as amino acid. So then the next question will be, what name an amino acid, or which of the following is an amino acid? The answer will be proline. So proline has a amino structure. Okay, proline has a amino structure. So this is carbon, hydrogen, and the third carbon forms a cyclical structure with a bonding with NH2, which leads to a cyclical structure, and we have got an amino acid. So the question will be, which of the following is an amino acid? The answer will be proline. Also, this is an alpha amino acid because it is again the alpha carbon where all the interaction is happening, and it's a 5-membered ring. You can see 1, 2, 3, 4 and 5. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and this is a 4th, 5th is a nitrogen. And such kind of ring is called as pyrrolidine ring. Okay, pyrrolidine ring is such kind of a. So this is the third, fourth MCQ which I am discussing. So which amino acid will have pyrrolidine ring? The answer will be amino acid proline. Okay, so this is there. Also, why is this structure very, very important? Because this structure favors the triple helix in collagen. So again, this is a question which will be very frequently asked. Which of the following amino acid is formed in the triple helix structure of collagen? The answer will be proline. Also, it favors the triple helix structure in collagen but interrupts alpha helix structure in most globular proteins. So this is about the Ketan, we will be discussing the deuterion, the pH. Don't worry about it. This is just the start of the lesson. So is everybody clear about general structure of amino acid? General structure, why all amino acids are called as alpha amino acid, why certain amino acids are called as beta. So if some amino acid is beta amino acid, so basically what happens, this is the alpha carbon, so the functional group will be on the beta carbon. Okay, so beta alanine. Okay, so now a very simple question, identify these amino acids. Identify these amino acids. Quickly write in the comment if you know what is amino acid 1, what is amino acid 2, and what is amino acid 3. I'm waiting for some time before I take the next slide. Just write in the comment, identify what is the first amino acid, what is the second amino acid, what is the third amino acid. Now we know that there's a lot of image based questions, so identification of amino acid can be one of those questions. Quickly, what is the first amino acid, what is the second amino acid, and third. Good. So first is basically glycine. So here the site first is glycine. So here the side chain is basically the hydrogen. Okay, so there is no carbon. These three are constant for all amino acid, as already told you. So the side chain here is of hydrogen. Okay, this is glycine. This is alanine. Okay, this is alanine. Very good, Ketan, very good Deepu, very good, right? So this is alanine. Here the side chain increases by one carbon. Okay, and this is serine. What happens here? It is still the one carbon, but there is one hydrogen OH also attached. So this is serine. So glycine, alanine, serine. Okay, is it clear? Now all these three are non-essential and all these three are glycogenic. Very important to remember. Okay, so glycine, alanine and serine, all these three are very simple amino acid. They have very similar structure and they have very similar properties also. No, 2 is alanine. Okay, 2 is alanine, only one carbon side chain, and this is serine. Okay, this is serine, C with one OH. So is everybody clear about these simple amino acid, glycine, alanine and serine? Okay, let me move to the next two amino acid. Can you all write on the structure which is number 1 and which is number 2? Which amino acid is number 1? Which amino acid is number 2? Quickly, can anyone write which amino acid is number 1? Which amino acid is number 2? Quickly, can everyone write? So basically, if we see here, again, so what happens is, this is our general structure. Till this is the general structure, but this is what is different in here. So this is the side chain here and this is the side chain here. So they are absolutely same. The only difference is this is having an OH group. Okay, so basically this is phenylalanine. This compound which you see, this amino acid is phenylalanine. Okay, and this is tyrosine. The only difference between phenylalanine and tyrosine is an OH attachment. So tyrosine. So what happens when phenylalanine is hydroxylated? When we hydroxylate phenylalanine, very good Alpesh, very good Deepu. What happens is when phenylalanine OH group is added, hydroxylation reaction happens, it becomes tyrosine. So few important points which you can already remember is the enzyme which will convert phenylalanine to tyrosine is phenylalanine hydroxylase. Another important concept is phenylalanine is an essential amino acid, tyrosine is a non-essential amino acid. Okay, and in fact tyrosine is the only aromatic amino acid which is non-essential. All the other three aromatic amino acids are essential amino acids. Okay, and both of them are glycogenic and ketogenic. Again, both of them are glycogenic and ketogenic. So these are various important points about phenylalanine and tyrosine. Very good. So all these questions can be asked. Let's look at what is this group. This is a structure of tryptophan. Can anyone tell me what is the name of this group? You know, this structure which we are seeing here. What is the name of this group? Very important group. A lot of questions has been asked on this group. What is the structure of this? Good, Nivas. Very good. What is the structure? What is the name of this group? Quickly. So basically this is an indole group. Very good, very good. So this is an indole group. This is a structure of tryptophan. So what happens? This is our common. This is CH2 and this is the indole group. Indole group, they are basically, it's a bicyclic group. So there are two cycles, one of 6 carbon, one of 5 member, and here we have got a nitrogen. Okay. So we will learn a lot about tryptophan in coming sessions. So it is glycogenic and ketogenic, aromatic, heterocyclic, essential amino acid. Okay, you have to remember that all aromatic amino acid. Okay, all aromatic amino acid are essential. The only exception is tyrosine. Just now we have talked. Okay, right? And so is it clear? Okay, let's look at this. Identify these two structure. Structure 1. No, Deepu. No, it's. So identify the structure 1 and structure 2. So if you see, this is the same. Okay, this is the same. The only difference between this structure is it has CH2SH sulfur, and it has, this group has got CH2S and CH3. Okay, so basically if you see, the correct answer is this is cysteine, this is cysteine, and this is methionine. Okay, both of them are glycogenic. This is non-essential and this is essential. Now one important point I will tell you is, here the sulfur is very exposed. In cysteine the sulfur is exposed. This hydrogen can easily be lost. Okay, and this sulfur is now ready for reaction. but here this methyl group cannot be lost. Okay, so this sulfur is not available for reaction. So a very common question which will be asked in this will be, why methionine does not give sulfur test? Because the sulfur in methionine is not available for reaction, whereas the sulfur in cysteine is available for reaction. That is why, you know, cysteine gives sulfur test. Is it clear? Very good, Sikandar. Very good. Very good. So is everybody clear why cysteine will not give a cysteine will give a sulfur test, whereas methionine will not give a sulfur test? Because the sulfur in methionine, this, if you see, this methyl group cannot be easily lost. But we all know that this hydrogen can be easily lost. Okay, and so this sulfur becomes exposed. This sulfur is available for reaction. That is why cysteine will be available for reaction, and that is why it will give sulfur test, whereas methionine will not give. Very important question. Now, cysteine can be made from methionine, so it is non-essential. What is the meaning of thiol group or thioalcohol group? We know that alcohol is OH. Similarly, SH we called it as thioalcohol or thiol group. Here it is thioether. We know thioether is basically SOS, right? So so there is a sulfur, sorry, RSR dash. Okay, so there is a sulfur on B side. There is a, okay. So can anyone identify branch chain amino acid 1, 2, and 3 quickly? What is amino acid 1? What is amino acid 2? What is amino acid 3? Very quickly. Good. Very good. Okay. So basically the first is valine. So this first amino acid is valine. This is leucine and this is isoleucine. Okay. Again, this is 3 carbon. These are branch chain amino acids. So this is 3 carbon. Okay. This is again 4 carbon and this is 4 carbon. That is why both have the same name. They are isomers. That's why isoleucine, leucine and isoleucine. Okay. So here it is, you know, attached on the second carbon of the side chain. Here it is on the this carbon. Okay. Very important to remember, all are non-polar, all are essential, all branch chain amino acid are essential. But very interesting is, this is glycogenic, this is ketogenic, and this is both glycogenic and ketogenic. Okay, a very good way to remember all the glycogenic and ketogenic amino acid which will be both glycogenic and ketogenic is FIT. F is for phenylalanine. Okay, phenylalanine is single represented by E. I is isoleucine. T is tyrosine. Okay, and last is tryptophan. Okay, these FIT amino acids, remember FIT means they can create both glucose and both ketones. So these FIT amino acids are basically both glucogenic and ketogenic. And lovebirds, I call it lovebirds means leucine and lysine. These are the two lovebirds which will be purely ketogenic. Rest all are purely glycogenic. Okay, so is everybody clear about branch chain amino acid? Again, very important structure. This is 3 carbon, this is 4 carbon. It is on the second carbon, this is attached, this is again on the second carbon, and this is on the isoform. Okay, now can anyone identify these basic amino acids 1, 2, and 3? Very important, basic amino acids. Can anyone identify what is amino acid 1, what is amino acid 2, what is amino acid 3? Quickly, can anyone identify what is amino acid 1, amino acid 2, and amino acid 3? Okay, so and let me tell you a very important point. Okay, so if you see, it has an additional amino group. That's why it is basic in nature. Okay, here also if you see amino group, additional amino groups. Okay, so and this is a very special group called as guanidium group. So this, what is guanidium group? C attached with 3 nitrogen. Very beautiful. 3 nitrogens. Okay, C attached with 3 carbon attached with 3 nitrogens. Guanidium group. And this is an imidazole group. Imidazole group is a basically aromatic group with 2 nitrogen. Okay, so what are these amino acids? Let's look. So this is our lysine. This is lysine. Okay, simple 4 chain carbon with NH2. This is arginine. Arginine having again guanido group. Again, it has 4 carbons only, 1, 2, 3. But the 4th carbon is having guanido group. And lastly, we have got histidine, which has this imidazole group, 2 nitrogen in the cyclic compound. Is it clear? Now you have to remember that all these basic amino acids are essential amino acids. Very important. All these basic amino acids are essential. Lysine is ketogenic and both of these are glucogenic. Okay, lysine is ketogenic and both of these are glucogenic. Now, can anyone identify this acidic amino acids and the counterpart? Okay. So if you see here, one has basically this CH2 with a COOH group. Okay. And this is CH2 with a amino substitution. Okay, so this is basically aspartic acid and aspargine, the derivative of aspartic acid. Okay, if you see, can anyone identify this? Here if you see, there are two carbons, similar structure, but rather than one carbon it is two carbon, right? And here it is glutamic acid with glutamine, right? Now again, if you know this structure, you will be very easy to, whenever I am discussing the, very good Deepu, it's very good. So when I am going to talk about the reaction, you will be understanding in a much better way. Okay, so now let's look at special groups. So we have seen this is thiol, this is thiol. These groups, why I am taking special interest is because there will be special questions on this. Okay, right? Phenylalanine and tyrosine, it has a benzene group, it has a phenol group. Okay, arginine already discussed, it has a guanido group. Histidine, it has got an imidazole group. Okay, tryptophan has an indole group. Remember, it's not imidazole group. In tryptophan, it is an indole group. Indole group will basically give that, that dye, indole dye. Okay, and proline has pyrrolidine group. Okay, pyrrolidine, the 5 carbon with 1 nitrogen, 4 carbon with 1 nitrogen, 5 membered ring. So is everybody clear? Now coming to your question, I think someone asked, Ketan Reddy asked about pH deuterion concept. So that is what I am going to cover. So we have seen that there are two different kind of groups. One is an acidic group, okay, one is an acidic group which is COOH, okay, and one is a basic group, which is NH2 group. Now acidic group, whenever there is a base, whenever there is an excess of base, which means whenever there is an excess of OH, what will happen? It will lose its hydrogen, okay, and this hydrogen will go and interact with this excess base to form water, and itself it will turn into COO negative. Okay, it will turn into COO negative. Whenever there is an excess, and what about the basic group? Whenever there is an excess of acid, so there will be an excess of hydrogen ion. This hydrogen ion will be accepted here, and this will turn into NH3. Very important. First, understand what happens when a COOH group is exposed to base. So this is an acid group. Whenever there is an excess base, it will neutralize the excess base by giving the hydrogen ion. Okay, basic, whenever there is an excess of acid, this basic group will accept here. So basically amino acid, whenever extra acid comes, the COOH group become active and give its hydrogen to neutralize the, whenever extra base comes, the COOH group becomes active, give its hydrogen to neutralize the base, right? And whenever extra acid comes, the NH2 group becomes active and takes the extra hydrogen. Okay, so basically amino acid has both the fire power. It can neutralize an acid also, it can neutralize a base also. Is everybody clear here? Now, so what will happen? So if you see, the COOH group can exist in two forms, as COOH or as COO negative. Okay, and this NH2 group can exist as NH2 also and NH3 also, depending upon the pH. Okay, so first of all, that is the main concept we have to understand. Okay, so what happens? There is an isoelectric pH. There is an concept of isoelectric pH. At isoelectric pH, what happens? There is no additional, so the pH of the medium is actually in sync with the pH of the amino acid. So what happens? There is an absolute balance of acid and base. So because it is isoelectric, there is a balance of acid and base in the amino acid in the aqueous solution. So what will in that situation, what will happen? All the COO will exist as COOS and all the NH3 will exist at this. Okay, so this is isoelectric pH. Now, which means all the COOH negative will exist as COO negative and all the NH2 will exist as NH3 plus. Now in this medium, what will happen? At this point, it cannot accept any OH atom, it cannot accept any hydrogen atom, because if you put OH, this COO does not have the hydrogen ion to neutralize it. If you put hydrogen ion into it, this cannot be accepted here. So this is isoelectric pH. So let me show you what is an isoelectric pH. So this is what happens at isoelectric pH. Okay, this is what happens at isoelectric pH. This COO has, this hydrogen has come from here and come here. So this exists as NH3 plus and this exists as CO2 negative. Now in this atom, what will happen at this state, at this isoelectric pH, if we add hydrogen, okay, it will not be neutralized by NH2. If we add OH, it will not be neutralized by COOH. Is it clear what is isoelectric pH? Now, so what will happen at isoelectric pH? At isoelectric pH, there are certain things which you have to understand. First of all, it exists as a zwitterion or ampholyte, which means what is a zwitterion? It will have both positive as well as negative charge. Okay, so you see at isoelectric pH, it is having both negative and positive charge. That is why it is called as ampholyte. But the important thing is there will be no mobility in the electric field. Why? Because the net charge is zero. Okay, there is one negative charge here, there is one positive charge here, so the net charge will be zero. There will be minimum solubility and maximum precipitability. Why is that? Because each molecule is relatively charged. Okay, each molecule is charged within itself. So what will happen? Because all the other molecules are also charged, they will tend to have electrostatic interaction and they will have minimum solubility. Because if charged molecule are there, what will happen? They will have electrostatic interaction. So this negative will interact with some positive, and so there will be bond formation, electrostatic bond formation, and minimum solubility. And also, as I told you, there will be minimal buffering capacity, because when the amino acid is in this state, if you add hydrogen, this cannot be accepted by any, because all the amino group is already protonated. If you add OH, it cannot be neutralized because all the COOH has already lost its A. So it has minimum buffering. So this again forms a very, very important set of questions. At isoelectric pH, what happens? Okay, isoelectric pH, the amino acid exists as a zwitterion. At isoelectric pH, there is no mobility in the electric field, because even though they are charged, overall the charge is neutral. Each amino acid will have zero charge overall. There will be minimum solubility and maximum precipitability and minimum buffering capacity. Now, important thing here to understand is what happens when the pH is less than isoelectric pH. So when the pH is less, which means there is more of hydrogen ions, there is more of hydrogen ions. Okay, if there is more of hydrogen ion and less of OH ion, then this will exist as COOH, but this will exist as NH3. So overall, the amino acid will be in a protonated form. What happens when the pH is greater than at the isoelectric pH? When the pH is greater, when it means there is an excess of OH. So if there is excess of OH, this NH3 will exist as NH2, and this COO will negative as COO negative. Okay, and it will be in deprotonated state. Is everybody clear what happens at in zwitterion and isoelectric pH? Okay, now another very important question is calculation of isoelectric pH. Okay, now each amino acid will have the different COOH group and NH2 group, and they will have their ionization potential. Okay, now if we see the ionization potential, like say alanine, the ionization pK of ionization of COOH group is 2.35, and the NH3 group is NH 9.6. So if we have to calculate the isoelectric pH, it will just be an average of these two. Okay, because this alanine has only one acid and one base group. What we'll do is we'll simply add both and divide it by 2. So this will be the isoelectric pH for alanine. Why? Because we have seen in the structure of alanine, there is only one pK, one acid group and one base group. What happens in aspartic acid, in molecules like aspartic acid, where we have got 2 acid and 1 base? Then what we'll do is whatever is the majority here, the acid is the majority, the acid group is the majority, we will simply take the average of the acid group. Okay, we will ignore the base, we will ignore the pK value of the base, we will simply take the average of the acid, and this is the isoelectric pH. Is everybody clear about the calculation of isoelectric pH? Is everybody clear about the iso? So it's a very simple concept. Okay, there are two kind of molecule. One which most of the amino acid are balanced, which means they will have one acid and one base. In those amino acid, it is very simple. We will simply add the pK value of one acid and one base, and you will get it. Okay, some amino acid are having more of acid, some are having more of base. So anyone with more of acid, we will average out all the acid pK. Anyone with having more than base, we will average out all the base. Now here what we get is an isoelectric pH. We have to understand that the closer the isoelectric pH is with the physiological pH, the better buffering agent that particular amino acid will be there. For example, histidine has a isoelectric pH very, very close to our physiological pH, and that is why histidine has the maximum buffering capacity. Very, very important MCQ. So whichever isoelectric pH, the closer it is to physiological pH, the better buffering agent that particular amino acid will be. And that is why histidine is having the best physiological, is the best physiological buffering amino acid. Is everybody clear about it? Is everybody clear? Okay. Now, coming towards the end, we will talk about optical isomerism. So, any amino acid, any carbon. So, for optical isomerism, what is optical isomerism? Basically, when the plane light is passed to an aqueous solution of anything, if the light is rotated towards right or left, then that is an optical isomerism. Okay. To have optical isomerism, we need in the structure, in the carbon atom, what we call is a chiral carbon. What is a chiral carbon? Chiral carbon, we know that a carbon can attach with 4 different molecules. Okay. A chiral carbon is when all the 4 different molecules are different. Okay. Suppose if we have carbon and there are 2 hydrogens, okay, and this is chlorine, this is bromine. So because these 2 are same hydrogen atoms, this will not be a chiral carbon. But suppose we have a carbon, we have 1 chlorine, 1 bromine, 1 hydrogen and 1 fluoride. So this becomes a chiral carbon. Okay. So if you see in amino acid, these 3 are already different. As long as the 4th is not hydrogen, amino acids will always be optically active. And there is only one amino acid which will be optically inactive, which is glycine, because glycine here the side chain is hydrogen, so these 2 becomes same. So only amino acid which is optically inactive is our simplest amino acid, it is glycine. Rest all amino acids are showing optical isomerism. Is this clear? Okay. Certain one-liners about optical isomerism, very important. So D form is called a dextrorotatory form or clockwise. It rotates the light clockwise. L form is levorotatory. It rotates the light anti-clockwise. All naturally occurring amino acids are levorotatory. In carbohydrates, see, most of the naturally occurring carbohydrates are dextrorotatory. Okay. Naturally occurring D amino acids, this is again a very, very favorite MCQ. Many times this has been asked in PGI. Free D aspartate, free D serine in brain tissue, D alanine and D aspartame in cell wall of gram positive bacteria, D subtilis and V cholerae incorporates D leucine and D methionine. So these are important examples of D amino acid. Now I will try to upload the link or download link of this particular slide so that you can download it for your revision. It will be in the comment section or in the description section. Okay. Now amino acid with no carbonyl chiral or no optical isomerism is glycine. Again, a very, very important MCQ. Source of D amino acid is human, is always exogenous, and the enzyme that converts L and D isomers are called racemase. Again, it's a very important MCQ. So this brings us to the end of our session. Okay, I have tried to discuss as many questions as possible. Now towards the end, I'll talk to you about our foundation course, NEET PG foundation course at Unacademy. Now, if now there are 2 ways to learn. One is when you are learning, self-learning everything, and one is when you are learning in a guided way with educators, in live classes. The only problem with live classes is that you have to travel, you have to go to a coaching institute, and because you are traveling, generally there will be 8 hours, 10 hours of classes in a day. Now nobody in the world can learn continuously for 8 hours. Now Unacademy gives you that convenience that you can stay at your home and learn at the convenience of your home in short spurts. Like say every day, even if you attend a 1.5 hour or 3 hours of session, the foundation course has been designed that every day there will be 2 classes, 1.5 hours each, which will help you to complete all your syllabus by August. And from August till December, there will be completely revision around NEET PG. Okay. So Unacademy gives you best of the live classes. Best is that suppose if you miss a live class, what will happen? All the sessions are already recorded and kept in the Unacademy course structure. So even if you miss, or let's say after some time towards the end you want to revise that particular session, you can easily go back and see the recorded session, and you can learn from it, you can revise from it. And if you want to subscribe currently, this is the best time to get on board. Top educators are actually teaching at live Unacademy, and the best part is that if you see the next PG examination pattern, what is happening is a lot of clinical oriented questions are asked. So for those clinical orientation question, even though it will be from the theory which you have learned, but you may not be able to think that such kind of question will come. But when you are interacting in a live class, the faculty actually tells you that this is the twist they will do, or this is the way it can ask you. Okay, so very very important that you know attend live classes. And if you want to enroll, recorded sessions you can find on YouTube, on so many other places, but interaction learning from live mentor is altogether a different experience, I keep on telling. And if you want to join the foundation course, use this code Dr. Abhishek 10, because this will give you an access to 10% discount. This will give you, if you use this doctor. If you want some other exclusive offer, you can go to Medico Apps. Medico Apps has an exclusive tie-up with Unacademy, medicoapps.unacademy.org/unacademy, and you know, you can schedule a counseling session there to understand if this Unacademy, you know, subscription is good for you or not good for you. And so overall, I mean, you might have attended few sessions by now by different educators. It's a very live learning, it's a participatory and a deeper learning for everyone. So hope you enroll in the, you know, foundation course and take the benefit out of it. So foundation course has the complete coverage till August and a complete test series to associate with live classes. If you have any doubt, put it in the comment section. I'll definitely take it. We have a next session at 9 o'clock where I will be discussing around the classification of amino acid in the same way. Thank you guys. Thank you. Have a great day.